Data conversion. Sometimes it's convenient to convert data from one type to another. For example, in particular situations, we may want to treat an integer as a floating point value. These conversions do not change the type of a variable or the value that's stored in it. They only convert the value as part of the computation. Widening conversions are the safest because they tend to go from small data type to a large one, such as a short to an int. Narrowing conversions can lose information because they tend to go from a large data type to a smaller one, such as an int to a short. In Java, data conversions occur three ways: assignment conversion, promotion, and casting. Here's a table of the widening and the narrowing conversions. So the idea is whenever you widen something, it's safe because you're going from a smaller data type to a bigger data type. But whenever you narrow something, it's not safe because you're going from a bigger data type to a smaller data type. Assignment conversions occur when a value of one type is assigned to a variable of another. For example, int dollars is equal to 20, but then double money is equal to dollars. Now, the value of dollars did not change. It's still 20, but Java saw that this was a 64-bit floating point value, and it converted this integer into a double when it assigned that value to the double variable. Only widening conversions can happen via assignment. Note that the value or type of dollars did not change. Promotion happens automatically when operators in an expression convert their operands. Example, int count is equal to 12. Double sum is equal to 490.27, the result of sum divided by count. So since sum is a double, this calculation will be promoted to be a double. The value of count is converted to a floating point value to perform the division calculation. Casting is the most powerful and dangerous technique for conversion. Both widening and narrowing conversions can be accomplished by explicitly casting a value. To cast, the type is put in parentheses in front of the value being converted. So here's an example. Int total was 50, and then you have a float result. They're casting total to a float and then dividing it by 6 so that this operation can be treated as a float and it won't lose any resolution. I'll go ahead and do an example of this. Without the cast, the fractional part of the answer would be lost. I made a class called casting example. I'm going to go ahead and compile this to make sure I haven't messed anything up. So I'm going to go ahead and do some demonstrations of the things that we just talked about. So I have a variable called result as a float, and it's going to be set equal to the value of a divided by 2. Now a is an integer, and 2 is also an integer literal. So when Java sees two integers being divided by each other, Java's going to treat this as an integer. So the result of this would be 7 divided by 2. 7 divided by 2 is 3.5. However, since Java sees this as integers, the result of this is going to be a 3. So now we're putting a 3 inside of a float. What's going to happen is result is going to be equal to 3.0. I'm going to compile, run, and you can see we got 3.0. Now if we wanted to force this to be a float, we have two options. I think the easiest option is just to put an F there and we can compile and run, and now we got 3.5. The alternative to this would be to cast the a into a float. This is just telling Java, force this a to be a float because a is an integer, and I want it to be a float just for this calculation, and I get the same result. So the reason why narrowing conversions is dangerous is because if you have a large value stored like in a 64-bit number and you try to narrow that, you can lose a lot of that precision. So let me do an example of that. Okay, so I made a double and I assigned it this value, which is a very small fraction. I'm going to go ahead and just print this out so that we can see what it looks like. We've done something like this before, and the output was in scientific notation. And again, I get the same thing. Okay, so now what I want to do is I want to force b to go inside of result 2. Result 2 is an integer. Now when I do this and compile, I get this error here where Java immediately recognizes I'm trying to force a double inside of an integer. But since this is such a small fraction, if I were to force it inside of an integer, it's just going to be 0. But I'm going to go ahead and do that anyway. I'm just going to come over here and force this to be an int by casting. Let me run this again. And you can see that it's 0. So the reason why it's dangerous is because you have this number that can hold a very small fraction, but now you're forcing it into an integer and you're going to lose all that data. You just have to be careful when you're using these types of things. Okay, so I went ahead and set up another example for casting. I have my integer a is equal to 7. I made a result, but this is a byte. So if you remember, a byte can only hold 256 possible numbers. The lowest value is negative 128 and the highest value is 127. So when I assign result to A is 7. So I'm storing 7 into result, which is a byte. It should be fine. But when I compile, I get an error. Now, the reason I'm getting an error is even though this integer has a 7 and this is a byte, I'm still storing it into a byte, which is 8 bits, and this A is 32 bits. So Java doesn't care. It's just saying, hey, that variable is 32 bits. I don't care if there's a 7 inside of it, but you're trying to put that in there, and the result is 8 bits. If you really want me to put that in there, you're going to have to cast it. So I'm going to go ahead and cast it. And you can see that I got a 7. So everything seemed to work. But what do you think will happen if the integer is outside of the range of a byte? So the highest possible value for a byte is 127. So I'm going to go and set this to 127. Compile and run, and you can see that my byte does have the 127. But if I go higher, let's just say to 128, now I'm outside of the range of a byte. So when I compile and run, you can see that it's negative 128. So what happened was it went so high that it basically flipped itself. Now it's back on the other side, the lowest possible value. If I were to make this a 129, then the result of this would be negative 127, right? And if I were to make this 130, it will just keep going up. Okay, so it's important to keep this in mind, that's why when you cast, they say it's dangerous because integer can be 32 bits, a byte can only be 8. So once you go outside of the range of a byte, you're gonna get unexpected results.